Ooh. Nice. Anything else? Fatigue, don't you have to do that? Oh, so big in basketball. I'm like, yeah. And they usually miss the first one to sink their second one. I don't know. All right, sorry. Hand up here. What'd you do?
We did golf.
Nice.
Yeah.
Classic hockey players. Okay.
Like you have to feel the wind.
You
have to, like if you're putting, you have to like see how the ground kind of, like the terrain.
Yeah.
I don't know.
I played Tiger Woods golf. I know.
What?
Outdoor, like when there's a lot of fans, just like
Yeah.
yourself and just focus on your shot.
Yeah. Ooh, good one. Ooh, that's good. I didn't even have that on my list. Nice. Okay. Tennis, volleyball. What sports can I name off? Swimming. Oh, yeah.
We had volleyball.
Nice.
We said like depth perception, like so when you go for a hit, and then like visual perception of like coordination with like the ball with your hand, and so like proprioception in general, and like we included like auditory because like everyone's like screaming around and
Yeah.
like,
Same thing. Yeah.
and I guess we could include like fatigue like in your legs, because you like have to like move around and like jump.
Yeah. And adjust if you can't jump quite as high. Now you have to hit the ball in a different spot. Yeah, it's great. And something that, these are all things too that you can imagine if you're, well, you guys know this from being athletes, that if you're naive to something, you start doing it for the first time you go to spike a volleyball, you're terrible and then get better. Unless you were great at it. I'm terrible. Anyone else want to give us their sport? There's your chance. We'll move on. No? Okay. Good job. That was really just a break. I'm not going to give you those are all excellent. Okay. And I was just trying to bring in actually sports examples because this is real heavy on the anatomy and stuff like that this lecture. So next lecture we'll have more sportsy stuff. Not that you guys really care about sportsy stuff. I mean, like everyone's really into the neuroanatomy today. Okay, so sensory neurons. So we need to incorporate all of that sensory information. How does that happen? Through our sensory neurons. So the peripheral sensory nerve endings serve as specialized receptors to detect conscious and subconscious sensory information. We gave some examples of all of that. So we already mentioned, I heard the word proprioception, which is great. So conscious receptors will show sensitivity to kinesthesia. So your body position, weight, movement of muscles, tendons, joints, all that kind of stuff. You got a bum knee, you can't jump quite as high. Proprioception, your relative position and the magnitude of the effort applied in the movement. That's the kind of thing of like, if you have your eyes closed, you know roughly where your hand is in space. I, the other day, almost dropped a wine glass, and at the last minute reached out and smashed it, and I was alone in my kitchen. It was glorious. Reflex and good proprioception. My cats were there, but no one knew. They were not. Okay. Sounds so cool. Okay, temperature, sensations of light, sound, smell, taste, touch, pain, all of these things. And we talked about the light, the sound of the crowd, all that kind of thing. I always think it's funny, actually, that golfers need silence. No one else operates in silence. Why do they need silence? Is it better? Why don't you just all do it in noise? Anyway, does anyone, like a professional golfer of any kind here? Quasi-professional? Amateur? Yeah. Just the hockey players like playing golf, right? Okay. So, where was I here? Receptors, monitor, subconscious changes in the body's internal environment. Again, I'm not going to step on the toes of the cardiovascular, but we'll be talking a lot about this stuff. So, we have the chemoreceptors responding to changes in blood gas tension and pH, and the baroreceptors, our favorite, reacting to any change in arterial blood pressure. It sounds like I'm being sarcastic. This is the coolest reflex. We'll be talking about it. It's fun. And it's every day. Your baroreceptors are active right now. Well, actually, your baroreceptors are being unloaded right now. Okay. All right, and once again, I liked this image which I just found using Googs because it's got, I found, I told you, I'm so cool. I found a lot of these this one didn't have it, but I thought it was the best image, but a lot of them said not to scale, which I thought was really funny. So this is not to scale. If you want to write that onto your notes, you can. Because here's the skin. Again, here, going back to our example of touch, our free nerve endings of the sensory neuron, boo-ba-da-boo, up here to the dorsal ganglia and through the door. Again, love it. Here's our cell body hanging out inside the dorsal root ganglion, which is really nicely pointed out here. And then heading up into the spinal cord, again for transmission up to the thalamus. This is actually describing a reflex route right here with going straight to a motor output, but we'll talk about that on Tuesday. Okay, so basically integrating all kinds, this is I guess kind of an answer slide to what I asked you guys to do, but in a general sense, all the kinds of sensory. This is something that we didn't really talk about in our examples, but you know, again, your blood pressure. Oh, this was totally me in my hockey game 2 Mondays ago. I missed hockey this Monday, which was upsetting, but when I started feeling really nauseous, it was because my blood pressure was crashing until my vessels were vasodilated, and I actually didn't sense it consciously until I started to feel nauseous, and then I sat off for a few shifts, because I'm a big baby. But anyway, so that was something that was getting integrated by my body into the movements, and would have eventually resulted in me vomiting, which would have been terrible. And Gordon, have you guys had Dr. Bloom? He was like, oh, you never would have lived that down if you puked on the bench and stuff hockey, so I'm glad I sat off. Okay. So those were ascending nerve tracts. What about the descending nerve tracts? So axons from the brain move downward through the spinal cord along 2 major pathways. I always hated these when I was in undergrad because it seemed like a lot to memorize. The pyramidal lateral tract and the extrapyramidal ventromedial tract. The nice news is, the good news is that the pyramidal lateral tract is named nicely because they're lateral here. And the ventromedial, so again, ventral, we talked about the ventral horn. This is the front side. Yeah, medial, because it's to the inside. Okay, it just really helps you to realize where they are in the slice. So the pyramidal or lateral tracts, does anyone have a fun mnemonic remembering these? No? You don't have a cool anatomy? All right, that's too bad. If anyone thinks of one, you let me know. So the pyramidal or lateral tract will activate the skeletal muscle vasculature in voluntary movement under direct control, and those nerves will activate alpha motor neurons, again, stepping on the toes of Tuesday's lecture a little bit there, but we'll get to it. Corticospinal tract, which is part of this pyramidal lateral tract, is the longest CNS tract in the body. That's a fun fact, I love it. And 2/3 of its axons originate from the motor cortex. So I'll show you my favorite figure of all time on Tuesday, which is the cool one of like the motor cortex, and it shows like the different sizes of all the body parts, and like there's a sensory one too, the homunculus. Have you guys seen that? Oh yeah, love it. It's so gross, but I just really like it. Anyway, again, I digress. So corticospinal tract originating from the motor cortex. Tuesday. Extrapyramidal ventromedial tract controls posture and muscle tone via the brainstem, and this is continual background level of neuromuscular tone. So, like I'm not really thinking about standing up in front of you guys right now, balance is one thing, but sort of the neuromuscular tone that keeps you upright so that you have less to think about when you're trying to make that pitch, baseball, I forgot to talk about baseball. Anyway, so you're trying to make your pitch, your hit, do whatever you're trying to do. You don't have to think about these sort of postural adaptations. Okay, next slide is scary, but you don't have to memorize it. So this is just to show you the different spinal nerves and all of these coming together. So again, you don't have to memorize any of this. I really just kind of felt like it was interesting, and it shows also what muscles, which as soon as I saw sternocleidomastoid down there, that's my favorite muscle. It's probably everybody's when you learned it. Is it everyone's favorite muscle, right?
Which one?
Sternocleidomastoid. Such a fun name. I don't know. I can't explain them in my brain works. Remember we learned it in high school? I thought it was very cool. It's this one, right? Okay. Yeah, it is. Yeah. Okay. Just pretend like it's everyone's favorite muscle for me. Okay. So afferent neurons, again, going at the CNS, are going to relay sensory information from receptors in the periphery towards the CNS. Efferent going away into the peripheral tissues. 2 types, the somatic and autonomic nerves. So somatic means body, somatic. So these are your motor neurons, which are going to innervate the skeletal muscle, and firing above a threshold always produces an excitatory response that's going to activate muscle. Again, I'm sort of like leaning into next lecture there. This is another thing I really liked about this, was all of the sensory Roots, did you guys take these neuro classes where you're like poking? Yeah. Did you poke each other in the face? Probably not. Sounds like something that would happen in the early 2000s when I went to school. Okay. Again, my jam, we're only going to talk about this really briefly here so as to not steal my own thunder later on. But the autonomic nervous system is your involuntary nervous system. So those motor nerves affect your organs that are not under voluntary control, so obviously not your skeletal muscle. Including like your heart, the smooth muscle in your airways, this is a dentist slide, that's why I put that in there. I would say the smooth muscles of the blood vessels. So the autonomic nervous system is responsible for maintaining homeostasis and is separated into two divisions. Sympathetic nervous system, anyone know like the fun way to remember the name of the sympathetic nervous system? What its like nickname is? I don't know if you call it a nickname. Eh?
Fight or flight?
Yeah, perfect. Fight or flight, exactly. Oh no. I took that too fast. So anytime you see a saber-toothed tiger, you need to run away. That was my example, right? Uh-oh. Well, just give me a second here. I tried to drink it too fast so as not to waste time. Okay. Parasympathetic tending to inhibit an organ system. I always think too, and this is what's the fun name for the parasympathetic? Oh, you guys! What was the best participation we've ever done? Nice. Okay. Okay, so sympathetic, I always think about this as like if you're driving a car, your gas pedal, parasympathetics, your brake pedal. Again, I'm really stepping on my own toes, so we'll stop there. The sympathetic nervous system has the cell bodies of its preganglionic neurons in the spinal cord. Obviously a preganglionic neuron is a neuron that happens before the ganglia, like the dorsal root ganglion, for instance, but these are different ganglia. So its cell bodies are in the spinal cord, and then sympathetic neurons are going to release norepinephrine primarily from the postganglionic sympathetic neurons to bind with, again, primarily adrenergic receptors in the effector organ. We'll talk about that. So, we got acetylcholine here in the ganglion, norepinephrine here. The parasympathetic nervous system has its cell bodies in the brainstem and the base of the spinal cord. So rest and digest, rest kind of affecting heart rate, that kind of thing. Slowing down heart rate. The digest, so we have these sacral spinal cord, so all of your internal organs. Eating, all digesting. Okay, and then acetylcholine released from the postganglionic neurons here, binding with cholinergic receptors, which are cholinergic receptors on the effector organ, which again we will talk about later. And to finish off, just a nice slide that I really enjoy, and I just wanted to include it for no reason. Again, you don't need to memorize this. But this again shows the chain of the sympathetic ganglia, because remember that's where their cell bodies are sitting. So preganglionic neurons heading out to those ganglia, and then postganglionic. I mentioned a lot earlier, that's where you can get a real propagation of a sympathetic signal. And then here's all of the things that the sympathetic nervous system does. I always thought it was the most fun fact that the sympathetic nervous system inhibits bladder contraction. So if you come in my lab, we do something where it's microneurography, and we put an electrode in your sympathetic nerve, and we can directly record your sympathetic nerve activity. And when someone has to pee, their sympathetic system starts firing like crazy. So if you hold your breath, it starts firing a lot. Like fight or flight, you get them to do hand grip exercise, and it fires a lot. So one time, I was assisting a friend of mine, and she was a new master's student, and she didn't want to screw up my study. So she was lying on the bed, and her sympathetic activity starts going up. We've been doing all these stressors, so it was going up normally, and then it will come back down. And then at one point she said, like, oh, I kind of have to pee. And I said, how bad do you have to pee? She's like, no, I'm fine, I can hold it. So like, whatever, 20 minutes later, I look up at the screen, and it looks like she's having like a straight up heart attack. Like her sympathetic nervous system is like firing like crazy. I looked and I'm like, I'm gonna say her name, you guys don't know her. Tori, are you okay? And she burst into tears and was like, I have to pee so bad. And so we had to like take everything out and let her run to the bathroom. She's like, I really don't want to screw up your study. And the idea is that your sympathetic, to stop you from peeing, the sympathetic nervous system fires like crazy. My supervisor, because most women's pee sitting down, We don't have to talk about that. But most men pee standing up. And my old supervisor would say, especially if you've been drinking, there's a chance that your blood pressure's down a little bit. You guys should really sit down, because as soon as you go to pee, if you had to pee really, really badly, your sympathetic nervous system will all of a sudden, when you go to pee, shut down to let your bladder contract and to let you pee. But your sympathetic nervous system also controls all the blood vessels in your legs, which are keeping your blood pressure up. So basically, it's possible that everything can relax and you can pass out. So, listen to the voice. On behalf of your female roommates as well, because it helps you so you're not peeing standing up when you're drunk. If you think your blood pressure's a little low, you feel a little dizzy, maybe sit down. That's nice. That's your fun fact. Courtesy of my old supervisor. Okay, so again, this is really just kind of fun facts for you. We're going to get more into parasympathetic and sympathetic in the cardiovascular unit. Okay, that's all I have. See you guys on Tuesday.
Yes. I still have to go get my eyebrows done at 11:30. We can work on top of it. We can actually sure, I'm gonna